Today's lesson is on combinations. This should be log page 10 in your logbook. I want you to recall with me, if you will, tree diagrams. Tree diagrams helped us to find the number of options that we had available if we could only pick one option from choices. For instance, if we had an ice cream problem where we could pick chocolate or vanilla, you can only pick one of those two options. And then for toppings, we had caramel, chocolate, and strawberry. And you could only pick one of those options. Tree diagrams help us in that kind of situation where we can only pick one option from our choices. Combination rules help us when we can pick more than one option, like if we wanted to pick two different toppings for our ice cream. A combination is arranging things where order is not important. Let's scoot this up so you can see. This is your definition of a combination right here. A combination is arranging things when order is not important. Yesterday and the day before we were working with permutations where order is important. And yesterday in class we talked about the pepperoni pizza and the pepperoni and the sausage pizza. And if I put the pepperoni on first and the sausage on second, it's the same as if I were to take the sausage and put it on first and the pepperoni on second. It's the same pizza no matter which order I put the toppings on. So they count as the same thing. You don't count it twice. Combinations are distinct. Distinct. Well, what does that mean? It means each one has to be completely different, not just rearranged. Okay, distinct means that they are completely different, not just rearranged. So pepperoni sausage pizza is the same as sausage pepperoni. But pepperoni sausage pizza is not the same as pepperoni onion. That's two distinct pizzas. If I want to calculate combinations, we cannot use the fundamental counting principle. Remember, FCP stands for, let me slide over just a touch, stands for fundamental counting principle. The fundamental counting principle. You cannot use that with combinations. We have to use a formula. Remember, just like with permutations, where we had N permute R, we now have NCR, which means N choose R. N is the total number of items that I have. R is how many I'm choosing. So remember, this is the total. This is how many I'm choosing. Oh, and I'm off the screen. Sorry. N is the total. Sorry about that. N here is the total. R is the number that I'm choosing. So N choose R. And the formula that I'm going to be using for N choose R looks a lot like the formula that we use for the permutations. It's still the total on top. Then you take the number that you're choosing and then you subtract the two. So it's N factorial divided by R factorial times N minus R factorial. The total number you're choosing, factorial, divided by, I said that wrong, I apologize, let's go back. The total number you have to choose from, factorial, divided by the number that you're choosing, factorial, and then you subtract the total you have minus the total you're choosing, factorial. Okay, so let's look at example 1 and make sure that we can do this. A certain pizza, I'm just going to scoot this over. A certain pizza parlor offers 20 different topping choices and is running a special on a large 3-topping pizza. How many pizza choices are available or possible? Well, first of all, why is order not important here? Order is not important because toppings on a pizza it doesn't matter which order you put them on. You're still going to get the same pizza because sausage pepperoni is the same as pepperoni sausage. What formula are we going to use? We're going to use NCR. And NCR is n factorial over r factorial times n minus r factorial. First thing we need to do is find out how many toppings do we have to choose from. The total number of toppings. The total number of toppings, according to our problem, there are 20 toppings that we get to choose from. This is my n. Then we need to figure out the number we're going to choose, number of toppings that we're going to choose. So the number of toppings chosen is 3 because we're choosing a large 3-topping pizza because that's what the special is. So that's my R. So now I'm going to do 20, choose 3. 20 toppings total, we're going to choose 3 of them. So that's 20 factorial divided by, can you see my dividing line there? 3 factorial over 20 minus 3 factorial. All right, is everybody okay so far? Let's do this arithmetic. 20 factorial over 3 factorial. 20 minus 3 is 17 factorial. So now we're going to list these out. So we have 20 times 19 times 18 times 17. Now look right here. I see 17 factorial here. So I'm going to stop. I don't need to list all the rest of those factorials because I know that my 17 factorial right here is going to cancel with the 17 factorial in the top. So I have 17 factorial, 17 factorial, they cancel. And now my 3 factorial is 3 times 2 times 1. And now I can take those numbers and see what they cancel with here. So I see that 3 goes into 18, 3 goes into 3 once, and into 18 6 times. And I see that 2 goes into 2 once, and into 20 10 times. So now I can multiply together, and all I'm going to do now is take my calculator and multiply. And I'm not going to stick the calculator on the screen right now because it's really pretty easy to do this multiplication. 10 times 19 times 6. And then we're going to see that that gives us 1,140 ways or 1,140 choices of pizza. There are 1,140 choices of pizza if there are 20 different toppings and I'm going to choose 3. All right, the Think Pink Club at SCHS has 20 members and needs to send 4 of them out to sell t-shirts. We need to know how many distinct groups of sellers can be formed. Why is order not important here? Well, because it doesn't matter if I pick Sam and Mary and Joe and Tina, or if I pick Tina first and then Sam second. It's still the same group. Okay, the formula that I'm going to use because order is not important is N choose R. So how many do we have to choose from? So N here is 20 members because there are 20 members total. How many of them are we going to send out? How many are we going to choose? We're going to choose 4-member teams. So we're going to do 20, choose 4. All right, so we're going to do 20 factorial over 4 factorial times 20 minus 4 factorial. And that gives me 20 factorial over 4 factorial. 20 minus 4 is 16. And when we work this out, we're going to get 20 times 19 times 18 times 17 times 16. I'm going to stop with 16 factorial because I see 16 factorial in the bottom and I know they're going to cancel. And then I have 4 times 3 times 2 times 1. 16 factorial cancels. And here I can see that I have 4 times 3 times 2, Well, 3 times 2 is 6. Okay, this is a 6 right here. And 6 goes into 6 one time. And 6 goes into 18 3 times. And 4 goes into 4 once, and 4 goes into 20 5 times. So now I'm going to multiply 5 times 19 times 3 times 17. Be very careful that you don't miss any of these numbers. And when I multiply that, I get 4,845 choices of 4 teams. Oh, sorry. Grabbed that paper and slipped it. Okay. Example number 3. Sam's Club has 4 senior members and 6 junior members on its board of executives. They need to choose 2 of each type to send to the conference. How many ways can they do this? This one's a little bit different than the last one. They have 4 senior members and 6 junior members on their board. Okay, 4 senior members. And let me see if I'm on the screen. Scoot this down just a touch. And 6 junior members. Okay. They need to choose 2 senior members, and they need to choose 2 junior members to go on this conference. Okay, why is order not important here? Because it doesn't matter if they choose Joe and Mary or Mary and Joe. It doesn't matter the order they choose them in. It's the same team. Now on this one, what we have to do is we have to do 2 different combinations. We have to do the first combination for the senior members. So we're going to do 4, choose 2, because there are 4 senior members and I'm choosing 2. And then I have to do 6, choose 2 for the junior members. So let's do 4 choose 2 first. So that's 4 factorial divided by 2 factorial times 4 minus 2 factorial. So that's 4 factorial over 2 factorial, 2 factorial, because 4 minus 2 is 2. So that gives me 4 times, let's move this over, 4 times 3 times 2 times 1, and I could have stopped right there. 2 times 1, 2 times 1. This 2 cancels with that 2, and this 2 will go into 2 once and into 4 twice. So I have 2 times 3 on the top, which is 6. And then I have just the 1 on the bottom. So there are 6 ways for me to choose 2 members of the senior team. Now I've got to do 6 factorial over choosing 2, 2 factorial over 6 minus 2 factorial. So this is going to give me 6 factorial over 2 factorial. 6 minus 2 is 4 factorial. So that's 6 times 5 times 4 times 3 times 2 times 1 divided by, I'm going to do 2 times 1 and then 4 times 3 times 2 times 1. Here's your 4 factorial, and you could have stopped with the 4 there. And then 2 goes into 2 once and into 6 3 times. 3 times 5 is 15. So there are 15 ways to choose the junior members. So I've got 6 ways to choose senior members and 15 ways to choose junior members. Now to figure out how many altogether, we have to separate the formula on this one. Okay, that's what we've done here. We've separated the formula. We've done a formula for the junior members and for the senior members. These are the junior members. These are the senior members. Now, in order to find out how many members altogether, we have to multiply 6 times 15. What we're doing is the combination of 4 things taken 2 at a time times the combination of 6 things taken 2 at a time. And actually, I've got that written backwards, and I apologize for that. And that's going to be 4 things taken 2 at a time is 6. I guess I do have it in the right order. 6 things taken 2 at a time, we found 15. And when we multiply 6 times 15, that gives us, what, 90? Yeah, because that's 30, carry, yes, 90. So there are 90 ways to choose people to go to this conference. Okay, example number 4. And this will be the last one. There are 20 cats and 14 dogs in the pound. So 20 cats, and there are 14 dogs. And I want to rescue or save 2 of each animal. How many possibilities are there? So I want to choose 2. Okay, 2 choices. I want to choose 2. And there's 2 choices of dogs. I want to save 2 of each animal. So I'm going to do 20, choose 2, and 14, choose 2. Now, why did I use combinations? Because order is not important. If I save the black cat and the tabby cat, it's the same as if I save the tabby cat and the black cat. So 20 choose 2 is going to be 20 factorial over 2 factorial times 20 minus 2 factorial. That's going to give me 20 factorial over 2 factorial. 20 minus 2 is 18 factorial. So 20 times 19 times 18. Now this time I'm definitely going to stop because I don't want to list all of those. So I know that the 18 factorial is going to cancel there, and then I just have 2 times 1. And 2 goes into 2 once and into 20 10 times. So now I have 10 times 19, which there are 190 ways for me to choose cats. Now if I'm going to do the dogs, I have 14 ways to choose the dogs. So 14 factorial, I'm choosing 2, so over 2 factorial, and now I'm going to subtract 14 minus 2 factorial. So 14 factorial over 2 factorial, and 14 minus 2 is 12 factorial. And this gives me, let's make sure I have room here, 14 times 13 times 12 factorial. And I'm going to stop with 12 because I know that the 12 factorial will cancel in the bottom. And 2 times 1, 12 factorial cancels. 2 goes into 2 once and into 14 7 times. And now I have 7 times 13. Is that all I have on the top? Yes. And that gives me 91. So 91 over 1. So 91 ways to save the dogs. And now to find out how many ways altogether, I'm going to do 190 times 91 to find out that there are 17,290 ways to save both cats and dogs. 2 of them. All right, that's it for today. Be sure you get all this copied down, and I'll be around to help you and answer questions.